Hey everybody, welcome to another calculus video, and today we'll be learning about the mean value theorem, also known as the MVT. Today we're going to be working with secant and tangent lines. So our theorem has a couple conditions. So first of all, f of x has to be continuous on a closed interval a comma b, and it has to be differentiable on the open interval a comma b. So, and if all of that is true, then there has to be a tangent line that lies on the interval a comma b that is parallel to the secant line. So let's draw all this out. So let's say we have any function. This can be any function. For example, let's say we have this parabola looking graph, and this point it will be a, and the y coordinate will be f of a, and this coordinate will be b, and the y coordinate will be f of b. Okay, so now we know that this function is continuous. We know that it is differentiable because it's a smooth curve. That means there has to be a tangent line with a point C in between A and B. So for example, if we draw the secant line like this, this will represent our average rate of change from the point A to point B. This is our secant line. There has to be a tangent line on this interval that is parallel to the secant line. So for example, I'll try to eye this out to make the lines parallel. So okay, in theory, these lines are supposed to be parallel to each other, which means that this point is C, comma A of C. Okay, so now let's do one practice example. We have f of x is equal to natural log of x on the interval 1, comma 4. First, we have to check the conditions. Natural log functions of x are continuous on their domain, and they are also differentiable on their domain because they're a smooth curve. So we can actually apply this theorem. So first we have to do is we have to find the average rate of change on the interval from 1 to 4. So first we're going to have to use this. So let's see. First we're going to have f of 4 minus f of 1 over 4 minus 1. So we're going to have the natural log of 4 minus the natural log of 1 over 3. So this is going to be our secant line, but since we're subtracting natural logs, we can actually divide them. So we're going to have the natural log of 4 over 1 over 3, and this is just the natural log of 4. So now I take the derivative of this function, which will be f prime of x is equal to 1 over x. And now that we know that the derivative, and we know that with the secant line, we know that at some point x, we'll call it c, that at some point c, the derivative has to be equal to the average rate of change. So we're going to set this up. Our secant line is natural log of 4 over 3, and for some x, this has to equal to 1 over x. So now we just have to find our x value. So we're going to cross multiply. We're going to get x natural log of 4 is equal to 3, and to solve for x, we just do x is equal to 3 over natural log of 4. Okay, so this will be our answer. And what does this mean? This means that on this interval, the average rate of change is natural log of 4 over 3. And the x value that we found means that at this x value, the tangent line to this point has the same slope as the slope as the secant line. So let's do question number 2. So here we have f of x is equal to square root of x plus 4 on the interval 0, comma 5. First, I want to rewrite this f of x as x to the power of 1 half, because we have a square root, plus 4 to the power of 1 half. And now, okay, sorry, let's do it a different way. We can actually, we'll just have x plus 4 to the power of 1 half. Okay, now we got to take the derivative. So we're going to have f derivative of x is equal to, we use the power rule, we bring the 1 half down. And now we're actually using the chain rule. We're keeping what's inside, doing this, and you have to times by the derivative of the inside, which is just 1. We can kind of get rid of that. Now if we simplify a little bit, we're going to get 1 over 2 x plus 4 square root. We found our tangent, our tangent equation. Now we got to find the average rate of change. So we'll have f of 5 minus f of 0 over 5 minus 0. F of 5 will equal to the square root of 9, which is just 3. And f of 0 will be equal to square root of 4, which is just 2. So it's just 3 minus 2 over 5 minus 0, which is 5. And this will equal to 1 over 5. Again, using the mean value theorem, we know that this function is continuous, it's differentiable, and now we can actually set the tangent line equation equal to the secant line, which is 1/2. There has to be a value x on this interval that satisfies the mean value theorem. So again, we can probably cross multiply, so we're going to have 5 is equal to 2 root of x plus 4. Divide both sides by 2, we'll get 5 over 2. Use the square root of x plus 4. Square both sides. So we're going to get 25 over 4 is equal to x plus 4. And then we subtract 4 on the sides. We get x is equal to, just do it on my calculator because it's faster. 21, 4 minus 4, equal to 9 over 4. Okay, so this is our answer. Thank you guys for joining me in this tutorial. Have a good day and goodbye.